Hi, I'm Wei Jing and I'll be presenting on my FYP project on GAN. Before we start, I would like to share this website with you. This website is by Justin Pinkney and it allows the tonification of a user input image where only specific features from the content image are stylized to cartoon-like. My project is inspired by this website and I will demonstrate the steps to achieve this tonification effect and some additional functions beyond the website. This is the flow of the video. I will first explain style GAN and tonification. Through re-implementing of tonification, useful analysis can be drawn to improve on current tonification model provided by Pinkney used in the website. To further expand the functionalities of the Tonify website, I conduct transfer learning on the FFHQ dataset and my collected style datasets to create tonification models supporting different resolutions. I further apply style mixing on the tonification models to generate stylized images with more effective control of style features. Tonification will make use of style GAN, which allows the synthesis of human faces with multi-level control of facial details and styles. These are example images generated by style GAN. This is an illustration of an interesting feature in style GAN, style mixing. The final image will inherit different styles from each source, depending on the resolution where the style mixing occurs. The lower resolution layer will control the coarse styles such as pose and glasses, and high resolution layers will control the fine styles such as colors. Tonification is done by interpolating between two generative models of style GAN. It utilizes the characteristic that different features in the synthesized image are controlled by different resolution layers in the style GAN model as we've seen previously. To obtain the transferred model, we first fine-tune the base model based on the target style dataset. After interpolation of the two models, features of the transferred model will be used in low-resolution layers which control the coarse styles. And the high-resolution layers will control the fine styles. It will be taken from features of the base model. This is an example of image generated from the interpolated model as achieved in the Tonify website. It generates photorealistic faces with the structural characteristic of a cartoon, where we interpolate a base model with a model fine-tuned with cartoon dataset. This is the official tonification model used in the website, trained with Disney dataset. And after experimenting the resolution layers where the swapping of the two models occur, I realized this interpolated model failed to generate side profiles. At higher resolution layers, some faces are also blurry. To improve his model, I retrained the same Disney dataset through transfer learning of the same FFHQ based model, experimenting with different number of epochs. And this is my final interpolated model. My model does not have his limitations at any resolution layer. The improved outcome may be due to the suitable epoch number, which creates a model that is better at balancing the extent of tonification while maintaining the structure of faces as compared to Pinkney's. The transferred model can be used for style transfer directly. This brings inspiration that I can carry out style transfer with more vivid styles using transfer learning. Furthermore, the above outcome is not really satisfactory because it's quite difficult to tell the original content image from the resultant image. This could be due to the great difference in features of the Disney characters and feature of a human. I prepared 7 different training datasets as seen from the table above. Pixel is used to replace the Disney cartoon dataset because Pixel characters have more similar features to human. Some datasets are cropped and some are enlarged. They will all be trained using transfer learning from FFHQ dataset so we can get tonification models supporting different resolutions. This is the outcome of the transferred models from transfer learning. The expected result of the actor model is the generation of the actor's face on any random faces. And for the other 6 models is the generation of the original image with the respective styles. And as we can see here, the pixel model here is much better than the previous Disney model mentioned. In terms of both training and testing, my method is highly efficient as seen from the table above, and it can be carried out in real time regardless of the image resolution. This is an example outcome of my interpolated model, where the transferred model is a trained pixel model and the base model is FFHQ model. And this is essentially how Tonify website works. However, the website does not allow user to control the color and semantic features of the output image. My project achieved this by using the style mixing feature on the tonification model. This is an example output where the style mixing occurs at layer 8, which corresponds to resolution layer 64 of the tonification model. From the grid, we can see that the cost level characteristic of the image are controlled by A, which is at a lower resolution layer, while the fine details and color scheme are controlled by B, which is at higher resolution layers. So each subset of resolution layers control meaningful attributes, and when we interpolate the layer where the style mixing occurs, we can have control over both the high-level semantic features and fine-level color features in real time for different image resolutions. So this slide shows the effect of interpolation of layer where the mixing occurs. And this is essentially what Tonify website is unable to achieve. These are some future directions of my project. And this is what we have just covered. Thank you.